resale value, have a lower vacancy rate, and rent for higher per square foot amounts in office and in the leasable spaces. So there is some real benefit to be had there as well. Energy costs. So here's one thing to think about. When you have a solar panel installed, you pay for that cost up front. You're paying the 25 grand or whatever it is to have that array on your roof, right? That money is gone. It's done, but now you have sun rays coming on to that solar panel indefinitely. The cost of the solar rays isn't going to change. It's going to stay steady at zero, right? But if you're getting electricity from a grid, it's going to fluctuate up and down with supply and demand and with the overall regulatory environment. So if they're imposing more legislation to increase rates, whatever it may be, you might have that business risk hanging out there. When you buy solar panels, the one huge benefit, or wind turbines, or whatever it may be, is that that electricity coming out of that solar panel or that wind turbine, out of those converters, is going to be the same amount year 1 through year 50. But you can't say that same thing for electricity. So you really have a risk minimization measure there as well. And then finally, federal, state, and local incentives. This can really subsidize the cost to commercial and residential owners. There's tax breaks that really makes investing in sustainability a lot more attractive. Just like with the electric cars, those kind of things, you can kind of start to offset those things in your head. You can do a tax break, you can actually afford that car and see that if you drive it this much, you'll save this much gas over this lifetime. Assume gas rates at a certain rate. So just looking at the overall life cycle cost. Maybe you're paying a little bit more up front for an electric vehicle, or that really fancy air handler, or just really expensive windows, whatever it may be, but you're going to get those benefits, and they're going to be stable and minimize your risk overall as a company, as an individual, as a family, as a resident. Focus on quality, embodied energy of materials. Does anyone know what embodied energy is? Just think about it intuitively.
How much energy required to produce that or bring it there.
Right. So, and it's not even producing, those are probably the last two steps would be manufacturing, producing, fabricating, and getting it to your job site, right? But what happens before that? It had the raw material had to get shipped to the manufacturing site. That raw material had to be mined out of somewhere. So thinking about the embodied energy in a given item and then translating that into material selection, right? So those that have the lowest embodied energy but last the longest would be your most beneficial materials. So structural steel, which is highly recyclable. Structural steel usually has about 98 to 99% recycled content. So the steel that we have, maybe not in this building because it looks like a concrete building, but the steel that you have in a lot of structures around the city is going to be steel that's been reused over and over and over again. So that idea of embodied energy, and we'll touch on that more, but the idea that, yeah, it cost a lot initially back in 1940 when the original steel beam was made, and now that you're reusing it and recycling it, you're cutting out a couple steps, right? Cutting out the ore process and refinement process of that material. And so as you recycle and reuse materials, you're able to lower that embodied energy. This also goes for building renovation and historic preservation. So you're using something that's already in place. You keep the bones of the structure, the walls, the roof. You take out the things that might be less energy efficient, all the mechanical, electrical, plumbing systems, the windows and doors that might have low R values or resistance values to heat and cold fluctuations. So keeping that idea of embodied energy, we're not just going to waste it and tear it down and throw it in a landfill. We're going to reuse it and save all that embodied energy, or some of it. Non-toxics, durability, longevity, adaptability, and desirability. So basically, is that product amenable to another use? One of the examples we'll show down the road is we're using masonry for decorative pavers, right? So masonry usually goes up on a wall. When you tear down that wall, it doesn't maintain its structural integrity, but you don't have to throw it away. You can use it for the pavers for the next project that comes along. A lot of people like those antique pavers. They might buy them for their home. So that's another example of downcycling, but instead of going to a landfill, it's going to another useful purpose. And once again, life cycle analysis. So you're paying more up front for something that's a quality item. You might buy a nicer piece of clothing because it's a nicer quality. If you shop at, I don't know, my wife shopped at TJ Maxx versus Express. She shopped at Express, she feels maybe Express is a bad example. Something higher than Express wherever she shops. She'll know that that shirt is going to last a little longer than the Old Navy shirt that she bought 2 months ago, right? So she might spend a little bit more, but she's thinking to herself, well, I bought that Old Navy shirt and it tore apart after you wash it, right? So it's the same idea with pieces of equipment, with material choices, trying to make that connection between you get what you pay for. You know? So now we get into some of the systems and how they kind of relate to sustainability. So first, the social sciences, economics, psychology, sociology. So how does green building affect the economics of an individual corporation? So let's take the corporation level first, and we'll get into community and regional levels as well. So the economics of a corporation, you might spend a little more up front, but you're minimizing your risk of operation throughout the lifetime of that structure. You're also going to be able to sell that building for more money. When you do sell it, you're going to be able to charge higher rental rates, and let's say it's a typical office building, and have lower vacancy rates. So you're minimizing your risk, maximizing your opportunity, while incurring some upfront costs. Psychology and sociology. It's been shown that people who have windows to look out of, who are breathing fresh air, who feel that they're in a healthful environment, are more apt to be productive, have better ideas. If they're creative people, be more creative. If they're technological people, basically to do their job better in that environment. And then similar with psychology and sociology. Physical science, chemistry, physics, we talked a little bit about thermodynamics, how a water bottle is not a water bottle after it goes through the recycling process. Chemistry, what are these carpet fibers made out of? What's the latest new material that might be installed where the chemistry is somewhat dubious and we're a little concerned about what's in it, what's in asbestos. People would have asked those precautionary questions early on, perhaps a lot of the asbestos problems we have today could have been avoided. Life sciences, botany, biology, zoology, how does the built environment impact the ecological world around us, right? So from emissions of the buildings, the actual building materials themselves, the toxic water runoff that might come out of your building or out of your storm sewers, how is that affecting the local environment? Ecology, geology, meteorology, and oceanography. In terms of oceanography, we can think of maybe tidal power or using river and water currents for underground water turbines like they have right now in the East River, for example. You can also think of rising oceans, right? What is that impact going to be overall on global warming, whether you care as much about global warming as a political issue or not. We will have to deal potentially with higher seas and higher oceans and designing for that in our built environment and living with that as coastal occupants of the own coast. Right? Engineering, civil, construction, mechanical, electrical, environmental, all of those units working together to conceive a building that each system functions with the other. The architect's designing the angle of the structure, it's designing the positioning to the sun, how tall the windows are, how big the overhang is, what color the walls are, how reflective that paint is. Then in turn, the electrical engineer is designing the lighting system. The mechanical engineer and the plumbing engineer is designing the HVAC system that's powering this whole thing. So you have less of a heat load coming through the windows, less of a light load coming through the lights and reflecting off the walls. You don't need as big of an air conditioner, for example. So you have all these iterative cycles between the engineers working together throughout the process. Professional, architects, legal, and business. Remember, protecting yourselves in green buildings as a green building professional in terms of obligation. That is a new concern and should be a concern. People want to stay in practice. And then the business side, which is probably the biggest side, which is just convincing organizations and individuals that green building is not just about saving the earth, it's about saving you green money, right? It's about saving money, providing better quality of life for individuals, for occupants, for human beings, and animals and ecological benefits as well. Really trying to focus on that three-pronged approach. It's a much stronger position to be standing on than just a single leg, right? Think of that metaphorically as well. Three-point stance versus a single point. So we're going to do economics, botany, oceanography. So a systems problem, physical sciences, life sciences, engineering, environmental sciences, social, and professional, all working together in the built environment. Where all occupants of the built environment have responsibility, both professionally and socially, to accept this challenge moving forward. So in short, our resources right now are very much less than our expenditures, right? Oil, water consumption, material consumption, land consumption. So some of the projections, electricity demand expected to grow. I try to be really positive in the class because, in my opinion, the problems that we have today and the problems that we'll always have are mostly human-made. And so humans can work themselves out of human-made problems, right? It's tough for us to control the sun or the rotation of the earth and things like that. But in terms of human-made problems, human beings got us into these kind of messes: design, construction, environmental advocacy, and sustainability advocacy can get us out of some of these problems as well. So it's kind of a positive spin to take on. But right now, we're going to be a little negative and tell you about how dire things are. So, electricity demand expected to grow 76% between 2007 and 2013, which is now only, 18 years away. 4,800 gigawatts, a tremendous amount of energy. The average American household uses 12,000 kilowatts per year. Renewable-based generation expected to increase from 18% to 22% of overall capacity by 2030, which is an astounding number. It doesn't look like much because it's only 4%. But if you think about the gigawatts that are out there now and the gigawatts that will be created by 2030, it is a large number. But you can see that we still have a large oil and fossil fuel-based economy with respect to energy. Daily oil demand expected to rise 24% from 85 to 105 million barrels of oil by 2030. OPEC revenues from oil and gas exports will top $30 trillion between 2008 and 2030. Think of all the things we could do with $30 trillion. Fossil fuels are the primary source of energy today. However, peak oil is predicted by 2018 in all nations. What is peak oil? Ideas? What's that?
Maxing out oil production.
Right. So it's the crest of the wave, right? If we're on this curve, this is 2008, we're going downhill. That's the idea, is that we source as much oil from the world as possible at this point in time. Or 2018. So we're like right now. Kuwait is the final exporter projected to reach peak capacity. The U.S. produced 8.51 million barrels of oil each day in 2008, but we consumed 19.5 overall. A delta of about 11 million barrels per day. It's the energy stupid, right? So that's really what this comes down to. We can talk all we want about how nice it looks if we have really large windows looking out into nature and saving green spaces, but it's really getting down to energy and water use. Why is water use related very closely with energy?
We consume water to produce energy.
That's part of it. Also, when you consume water, you're consuming a ton of energy. How does water get to your house? How does it get treated, pumped, primed, and returned and recycled to your shower head, right? So think about if you live in California, especially think about the route that water has to take all the way through that state to get to Southern California. So it's really about the energy, and energy really revolves around the two elements of water and electricity itself. There's a lot of strategies that can contribute to both of those, really on the electricity side. Water consumption is pretty simple. We'll talk about landscaping for your proper environment, low flow fixtures. But electricity is really where it gets dynamic. That's everything from the designer all the way through the building location, all the engineering disciplines, and then also human behavior within a project, right? When I leave class tonight, I'm going to turn off the lights, right? There might not be professors that turn off all the lights. So the human element is where all of us can at least have a little bit of impact. So educating them. But first, let's talk about water a little bit. Less than 1% of the world's fresh water, about 0.007% of all water on Earth, is readily accessible for direct human use. More of us every day. Less than 1% of the world's fresh water is readily accessible. You can kind of see a demonstrable picture right there of where we're at. The U.S. uses 408 billion gallons of water per day. America, taking a 5-minute shower, uses more water than the typical person living in a developing country slum uses in a whole day. The water and sanitation crisis claims more lives through disease than any war claimed through guns. Approximately 3.5 million people die each year from waterborne